So this will be the solution to the test questions from geometry uh, topic under construction. Now, here we see the construction of the angle bisector. You see the given angle ABC, and then an arc has been sketched from point B, and from these two particular points, the same length, same distance away. Uh, Another two pair of arcs has been sketched also. Now that means upper angle must be equal to the lower angle. That is in fact what this picture is showing. Now let's look at the choices. Angle ABD, which is upper angle, must be the half of the bottom angle. In fact, that is not true. They should be equal to each other. Haha. Wait a minute, that means choice 2 would have been our answer. Number 3, it says angle ABD, which is the upper angle, has to be equal to the entire angle. That is not also true. The bottom one, the bottom angle has to be the half of the upper angle. That is not also true either. So therefore, our correct answer will be choice number 2. Now, number 2 here, we see that the seemingly two parallel lines construction by the corresponding angles. Now, so what we have to look for here is the description of two parallel lines. We're not talking about perpendicular, but rather parallel lines. Now, that would be the choice number 3 and number 4, but when you look into that, we are not looking at the alternate interior angles, even though this is a very popular concept, but here we are looking at corresponding angles. So therefore, our correct answer will be choice number 4. All right, let us move on. Number 3, the diagram shows construction of a perpendicular bisector. Perpendicular bisector is given by from the end of the line segment, same radius arc has to be sketched. So then only thing that which we are looking at is choice number 1. And number 2 here, it seems to be the halfway done sketch of a perpendicular line from a given point. In order for that to be accomplished, we should have another measure of the arc drawn here, a sketch of the arc drawn here. Number 3, it seems to be the line is passing through the midpoint, but we have no idea if it's a perpendicular or not. So as number 4. So number 1 is the answer. Now number 4, as we mentioned earlier, angle bisector. Sketch of angle bisector has to be consist of one arc and then the smaller arc, which will be choice number 3. Now number 5, we're talking about equilateral triangle. Now when we're talking about equilateral triangle, now here we see the measuring of this line segment alone, and we have no idea about the other two. But in fact, here we see that one measuring of one line segment and then copy of the other two. So in fact, our correct answer will be choice number 1. All right. Let us continue to number 6 here. We see that the arc has been sketched. It seems to be from point P. That means all these points are equidistant from point P, and then it seems to be a pair of arc has been drawn from this particular point here and so as here. This in fact is the construction of perpendicular line, a perpendicular line from point P. Now that's what we're looking at. Then here, if a line is parallel to a line, that is, we're not talking about parallel lines here. If a set of points equidistant from endpoints of a line segment here, I mean, that seems to be the pretty close in a way that we're talking about this line segment, even though M is the line. We're talking about inner portion right here. So, set of points equidistant from endpoints of a line segment, which means coming up from this particular point, is the perpendicular bisector of the line segment. Yes, that seems to be the closest at this point. Now, two lines are perpendicular if they are equidistant from a given point. If they are equidistant from a given point, that simply means these two lines can be equidistant, for example, but they don't have to be parallel or perpendicular. Uh, Now, two lines are perpendicular if they intersect to form a vertical line. Now, uh, two lines are perpendicular if they intersect form a vertical line. What if one line is a vertical in this way? So the best answer seems to be number 2, but the better way of writing it would have been a perpendicular line, construction of a perpendicular line from particular point P. That would have been the best description, which is number 2 seems to be the closest. All right, let us move on. Number 7. Here, which two sets of construction marks labeled 1, 2, and 3, 4 are part of the construction of the perpendicular bisector of the line segment AB? Perpendicular lines bisector has to be from endpoint. These two arcs has to be drawn, so that means first one and then the third one, which is choice number 2. Now number 8. Here, same as before, number 1. This is a construction of an angle bisector. Now, but which statement is not true in this particular question? Let's try to look at it. Angle EBF. EBF, which is the lower angle, has to be the half of angle ABC, which is true. BBF, which is the upper angle, is the half of entire angle ABC, which is also true. Angle EBF, which is the bottom angle, has to be congruent to angle ABC, which is the entire angle. That is not true. So third one would have been our answer. All right, let us move on to number 8. Number 8, since it's kind of quite difficult for us to look at, why don't we zoom in only for one section here. Now, when you focus on this section, you get to realize that from point C, an arc has been drawn. Point B, another arc has been drawn. Essentially, what we are looking at here is this is the perpendicular bisector right here. Now, that means this one is a perpendicular bisector, so as this line would have been perpendicular bisector to this line, and so as this one. Now, then we are looking at perpendicular bisectors of the size of triangle ABC. Fourth one is what we are looking at. All right, here, similarly to before, let us just focus on only one section right over here. And you see that the angle is given, and an arc has been sketched, and a pair of arcs has been drawn. This, in fact, is the construction of an angle bisector. Now, so then, we are looking at angle bisector. So we have this one is one possibility, or this one is the other possibility. Now, intersection perpendicular bisector, no. Intersection of perpendicular, no. So we're looking at first two choices. But intersection of an angle bisector of a triangle is the center of the inscribed circle. You see the circle has been inscribed. So therefore, our answer will be choice number 1, not number 2, because circumscribed circle would have been circle that is on the outside. And that's not the picture that we see here today. All right, next question, number 11. Here we see that it's a perpendicular bisector. Then which statement is not true? We realize that this line segment has to be equal to this one, meaning AC must be equal to CB. And the first one is true. CB has to be half of AB, which is also true. Now, AC must be 2 times of AB. In fact, AC is smaller than AB, so that cannot be true. So therefore, our answer will be choice number 3. All right, let's move on to number 12 here. So we see that two lines with the construction of corresponding angles. Then, which statement justifies this construction? It must be angle 1 and angle 2 is congruent, which would be this one. And yeah, that's about it. Yes. Let's move on to number 13. Here we have they want us to construct the equilateral triangle. Okay. Now that means we need a compass and a straight edge. So here we have compass. Now what are we going to do? First, we need to measure the length AB. So first what we need to do is we need to make a mark right over here and then bring it over. Let's make another mark right over there. So that means this distance from A to B is copied over here. Now, next one will be from this particular point B, bring it over. Now, I made up another arc. Since I didn't change the distance from A to this particular point must be the same as B to this particular point. That makes this one to be an equilateral triangle. Let's look at it. Pretty close, 59 degrees technically it says. All right. All right, there it goes. So we constructed the equilateral triangle from copy of this line segment AB. All right, let us move on to the next question here. We have to do the angle bisector. All right, then once again, we are using the straight edge and then a compass. So first step here is from vertex of the angle, we need to draw an arc. So that there it goes. Okay. Now, next, what we need to do is I need to go to the intersection between the arc and then the line segment. Now, I want to come a bit more than halfway, so let me just come up this much. Make sure that I have covered more than halfway. Do exactly the same thing on the other side. And there it goes. So we realize, oops, that seems to be our line. So I'm gonna just draw. Okay. So now what I have done is the green line right over here would have been the angle bisector of the angle ABC. All right, let us move on to number 5. Here, using a compass and a straight edge, we want to construct the line that passes through the point P and is perpendicular to line N. Then, once again, we will be needing a compass and a straight edge. Now, first, what we like to do is this. We want to come up to this particular point P, and then we want to go a bit more than the distance between the point and the line, and draw an arc. Now, what this one does is that it creates a small portion of the line, meaning line segment can be identified. Now, what we can do here is that from that particular point intersection, we can draw an arc that should be going more than halfway of this small line segment which we just identified, and then do from the other side. Then this intersection must be the equidistance from here to here, these 2 points, so it's point P. Then when you connect the point P and the intersection, we get to realize that the red line that we have drawn must be perpendicular and go through point P. All right, let us move on to the next question, number 16. Here, we need to construct an equilateral triangle with line segment RS. In fact, this is very similar to the previous question. So once again, what we're going to be doing is taking out a compass. Now let us put it over here, and then we need to stretch this one out. So what I'm doing is I'm measuring the length RS. Now, what I like to do here is that I like to draw an arc. It's got to be more than halfway right here. It's got to be passing through that because chances are that I mean, the third vertex will come along the midway of the line segment RS. So next arc has been drawn. Then this particular point becomes the third vertex. Now, next what we need is a straight edge. And just draw the line. From same point. There it goes. So that becomes, oops, that becomes an equilateral triangle using the line segment RS. All right, let us move on to number 17. Number 17 is same as one of the previous questions. We just have to get the angle bisector. So then once again, what we need to do is this. We will go to the vertex of the angle and open that up and draw an arc. From the intersection between the ray of the angle and then the arc, which we can just identify, draw another arc. We can change the spread of the compass if you want to. Well, in my case, I just kept it. And after drawing that, you will realize the intersection. So now, just have to bring this one over right over here. And draw a line segment through that intersection towards B. That becomes the angle bisector. Alright, that's it folks. See you guys later.